All right, class, today we're going to talk about the chemistry of life. All right. And do you understand that at the beginning of the year, I told you guys that in the universe, everything is made up of either matter or energy. All right. And life is a combination of both. Okay. Now, with energy, it's less tangible. It's harder for you guys to see, or you guys will be learning that more so when you guys go into physics, if you guys do choose to. All right. For matter, you guys can learn more about matter in chemistry. All right. However, life, to understand the concepts of life, you do need some fundamental knowledge, a little fundamental knowledge on matter and how it works, as well as how it changes. Okay, and that's what this section will be about. Okay, first off, what is matter? Okay, now matter is defined as anything that has mass. Okay, it's a derivative of weight, right? Mass, and it takes up space. So it also has volume. Okay, so anything that has mass and volume can be considered matter. All right, so think about it. Do you matter? Yes, you are a type of matter. Right, the bookshelf in your room. Yes, the water that you drink. Yes. Okay, what about the air that's in your room? Okay, now do you understand that as people walk into your room, that amount of air that that person takes up, the volume, is actually pushed out of your room. Okay, so the gas molecules, even though the density is very low, it is a type of matter. All right, you want further proof? Um, Blow into a balloon. Okay, your breath, the gas, it does take up space. All right, and it takes up the volume that your balloon blows up to. All right, or when you're inflating a tire, same thing. All right. Okay, now basic states of matter are solid, liquid, and gas. All right, three basic states of matter. Okay, now some of you might be thinking, hey, what about the fourth state of matter, plasma? All right, yes, there is a fourth state of matter, plasma. A very simple example can be fire. All right, however, some other scientists do consider plasma a derivative of gas. All right, plasma happens when you really excite your gas molecules, and they actually give off a fluorescence. Okay, and that's basically the fourth state of matter, plasma. It's kind of funny. The whole universe, the most common form of the state that matter exists in actually is plasma. All right. However, on the planet, it's mostly solid, liquid, and gas. Okay. Um, Speaking of the universe, all right. Basically, think about stars. Okay, stars, they are matter as well as energy. Okay, and the matter actually exists in the state of plasma, and of course stars are the largest entity in our solar system. Okay, so if matter has to exist in states, the majority of it does exist in the state of plasma. Okay, now don't confuse the states with types of matter. Okay, certain types of matter can exist in different states. Okay, very simply, you've got liquid water, right? You've got solid ice, that's the same thing. And of course, when you boil water, you've got a water vapor. Okay, so the same type of matter, which is water, can exist up to multiple states of matter. Okay, okay, let's visit the smallest unit of matter, and that is the atom. Okay, now for this class, here's some fun facts. If you guys really want to read through, pause and read through. Okay, however, the important thing that you guys have to know is that an atom, the smallest unit of matter, and elements have three main parts. All right, you've got your electrons, your protons, and your neutrons. Okay, of course, a guy named Einstein came along with the equation E equals mc squared. Energy equals mass times the speed of light c squared. And with this equation, we are now able to split an atom and turn one atom into another type of atom, all right? And in that case, of course, E is energy. There's a huge release of energy, okay? Anyways, fun facts, okay? Okay, electrons are negatively charged, all right? And that's what you need to know for this class. Everything else is fun facts. Protons are positively charged, all right? And another thing you need to know is that they do add significant mass to an atom, whereas electrons do not. They're very, 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 very small, and their volume is very, 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 very small, okay? Protons, on the other hand, they do add significant mass, all right, to an atom. Lastly, you've got neutrons. Okay, neutrons are large, and they do add mass to an atom. However, they do not add charge to an atom. They basically don't have a charge. Okay, they are neutral. Okay, now here's your generic model of an atom. Okay, and in my opinion, this is a incorrect model, but in my opinion, it is the easiest, simplest, best best for your buck model of an atom that you can come across. Okay, it is incorrect, but as far as accuracy and simplicity, you can't beat this model. Okay, very simple. Okay, the neutrons and protons are usually at the center, and this is called the nucleus of the atom. And of course, your electrons, which are negatively charged, all right, will be on the outside. Okay, and they don't really like orbit. They actually do not orbit. Okay, but they do exist in different energy rings or energy levels. Okay, different levels. Okay. Okay, now that you guys know what an atom is, what are elements? Okay, it's not Avatar, the Last Airbender, or Legend of Korra. Elements are not fire, water, earth, or air. Okay, elements are your different kinds of atoms. Okay, in the whole universe, there are many, many different kinds of atoms. Okay, and you can find them all in your periodic table of elements. Okay, these are all the different atoms that humankind, has discovered. Okay, and now the thing is, what makes each atom different? Okay, that we can call them different elements. Okay, now they differ by the amount of subatomic particles. Okay, they differ in the amount of electrons, protons, and neutrons. Okay, now because electrons and protons are charged particles, okay, if they differ in the amount of these things, that means that these different elements, these different kinds of atoms, will differ in their charges. All right, now this is very important. Okay, charges and the way they are, it's what gives an atom, an element, its very specific properties. Okay, for example, one unique chemical property of neon is that if you run it through a current, it glows and fluoresces a bright orange. Okay, mercury, right? It's a weird metal that used to be common in thermometers, not anymore, but it's a heavy metal that actually exists as a liquid in room temperature. Okay, over here, there's a picture of boron in which it can actually exist as a gas and a solid at the same time right next to each other. Okay, so very, very unique properties here. Okay, now, again, every different element, every different element gets its specific properties from the charges that the molecule, the atom, possesses. Okay, now if you guys want further clarification on properties. I can give you an analogy. Okay, let's look at Mr. Young. All right, Mr. Young's physical properties. Okay, I've got black hair. Okay, I've got a red, white, and blue Aloha shirt from Costco with humpback whales on it. Okay, so these are all physical properties of me. Okay, now chemical properties. All right, chemical properties can be Mr. Young is, either a hard teacher or easy teacher. Okay, whatever you guys think. All right, that's a chemical property of me. Okay, another chemical property could be I don't like to admit it, but I'm a little impatient sometimes. Okay, that's another chemical property of me. Okay, so here's the analogy. All right, chemical properties, how an element or atom behaves. All right, physical properties, how it looks. Okay, how it reacts under physical change. All right. Okay, if you guys have any questions on properties and how atoms and elements possess their own unique properties, please let me know. Okay. Okay, now, because certain elements, all right, remember before, the electrons are in different levels. Okay, certain atoms and elements may possess a similar property. All right, and it is because at the outermost level of their electrons, they may possess the same amount of electrons. Okay, so because of a similar amount of charges on the last electron level, some elements may possess similar but different properties. Okay, and that's how we have grouped the periodic table of elements. All right, for example, let's see. Okay, over here we've got like all the noble gases. Okay, so they all have a similar amount of electrons on their last ring. All right, it's all filled. Okay, and because of this, they're actually very non-reactive. Okay, you cannot combust them. You cannot heat them up to a certain degree, and they will not act differently. Okay, so because of this, because they have their last level of their electrons filled to the brim, they are very unreactive. Okay, and that's why they're all placed in the same group. All right. Okay, over here, okay, you've got sodium, potassium. All right, these are actually very reactive. Okay, and again, it's because on their last ring, they possess a similar amount of electrons. Therefore, their charges are similar. Therefore, their properties are similar. Okay, for example, sodium. If you separate it by itself, you throw it in the water, it'll actually explode. Same thing with potassium. Okay. Okay. How to read a periodic table? Okay. Basically, um, the number of protons an element has is the atomic number. Okay, and vice versa, the amount of protons an element has is also the amount of electrons that it has. Okay, you don't have to know too much about how to read the periodic table. Okay, just that right here, if you look at it, helium, it's got 2 protons, 2 electrons. Okay, oxygen right here, 8, so 8 protons, all right, 8 electrons. Okay, not too much you guys need to know about this stuff. Okay, there also may be what's called isotopes. All right, isotopes are slight differences in the same element. Right, they possess the same properties. Okay, the same. Okay, not similar, but the same. Okay, and that's because they have the same charges. Their protons and their electrons are the same. Okay, how they differ is that they differ by the amount of neutrons. Okay, so their mass may be a little different. Now, because of this difference in mass, isotopes may be unstable. Okay, and due to this, isotopes are what we use to try and carry out research on, fusion or fission. Okay, nuclear research. Okay, this has led to things like, nuclear power plants. All right, positively and negatively, nuclear bombs. All right. Okay, more examples of isotopes. Okay, here, different amount of neutrons. Okay, but the proton is the same. Okay, this is a nucleus. Okay, this confuses you. Don't even worry about it. All right, just know that there are slight differences in different elements used in nuclear research, and they differ by the amount of neutrons, and the charges and properties are relatively the same. Okay, electron arrangement. Okay, do you know that there are different levels, all right, that electrons exist in? And again, this is not a very accurate, but the ring model, that's the most simplest, uh, as accurate as you can get for simplicity. Okay, the actual way these electrons exist is that you guys don't need to know this. All right, is that there's a area, certain area or quadrant that these electrons will most likely exist in, and what they do is they actually vibrate. Okay, I know the simple model makes them kind of like orbit, but that's not really how it is. All right, they actually vibrate in a certain area or a certain level. All right, farther and farther away from the nucleus.